I think I've always been interested in science and technology from very early days. To understanding the way things work, the way our environment around us actually operates, but then also turning sort of some of the technology into sort of engineering pieces and how that can make a real difference to the way we actually live our lives. Adaptix started off looking in the healthcare business to bring this low-dose X-ray technology to produce rapid 3D images of the structure you're trying to investigate.
With X-ray, you have 2D X-ray and then you have CT. With ours, we were between the two.
When you start thinking about what this technology can do and its ability, you start running away with potentials.
The medical side of our company got big enough that we had the bandwidth to try imaging other things. And if you've got an X-ray machine, you throw different stuff on it, see what works.
So ATI were really instrumental. I use the word sort of catalyst, or facilitated the ability to take a technology and look at it in a different discipline. The ability to say, right, let's try and put this technology in and see how well it works in the composites world. And that ATI grant facilitated that to happen. And we've been able to sort of mature the technology with that support over the last sort of couple of years.
One of the standard techniques for inspection of aerospace parts is still the tap test, which has been there since the Industrial Revolution. You just go along, listening along the aeroplane wing, tapping to make sure it all sounds right. There's got to be a better way of doing this, with 3D data giving you actual images of what's going on inside the part. With what we do being so fitting around a wing above and below, you can really pull more data out of that part. With the ATI, I was able to take what is a small device that we've now actually used for veterinary applications, and I can grow it. And it enabled me to design and build a prototype. And then I have a capability now, through these grants, to image parts up to 3 meters long.
It has the potential to make a real big difference to the aerospace industry, not only to the manufacturing side, but also to follow through the life cycle of the aircraft.
If you've got data on the part when it was built, because you know what the structure was like when it was built, then you can see how it changes over time, and you just get more and more information about those parts.
With the time that it takes to take these sorts of measurements, you could be doing this whilst the aircraft is waiting to offload passengers and take passengers on board, whilst you're doing some measurements on the other side of the aircraft, which you wouldn't be able to do normally. If we're developing new composites and new ways of manufacturing the composites to be more efficient, that's going to be less fuel consumption. If we can, from the manufacturing phase, reduce waste, that's got to be a positive thing.
What grants like this do, working with the ATI, it gives you the bandwidth to be able to look around at other applications. It gives you the ability to just check if there isn't a really easy way that you can deploy that technology that you've already built somewhere else and be of benefit to another industry. So that's where things like an ATI grants have really helped us to work out what we're doing.
One of the things that we talk about a lot is working across disciplines, not just within Adaptix, but generally in the scientific community. How can one discipline help another? So you're looking at technologies from one area and their utilization in a completely different area, and that's exactly what we've got here. And I applaud ATI for the ability to think, well, although this is a technology that came from the health sector, it could have real value in a completely different world.